My name is Isabella Cooper, and I study biochemistry. Within biochemistry, you can choose different tracks, and so my biochemistry covered cancer metabolism, medical physiology, endocrine networks, these sort of things. And then I progressed into a PhD program, so covering pathology, physiology, and during my undergraduate degree and then into my PhD program, I wanted to study people who are chronically in ketosis. And my project, actually, my research project, my pilot project, was studying females who are chronically keto adapted. I'm interested in insulin hyperinsulinemia in a pathological sense. So we know very well what insulin does in terms of its life essential and it functions healthily, physiologically, but in the pathological concentrations, chronic concentrations, and how that progresses to the chronic diseases that we see and suffer today. And then I always find it interesting that there is so much research out there. There's actually a lot in studying type 2 diabetics, cancer patients, epilepsy, many diseases, Alzheimer's disease, and taking these people who have these conditions and either restricting their carbohydrates a bit or a lot, down to low carbohydrate, healthy fat diets, or all the way into ketogenic diets. Whether they are ab libitum, so people just sort of follow a plan that they're sort of loosely given or guided, all the way through to controlled studies. And what I found really interesting was there didn't seem to be any studies on normal people. So people, when I say normal, I mean people who don't have any health conditions, or normal in the sense that they're not high performance athletes, because about 80+% of us, 90% of us, we like to do a bit of exercise, maybe go for a run, maybe do some yoga, maybe go to the gym, but we're not high performance athletes, we're not competitive athletes. And so I felt that there was this really missing gap. And I often wondered, well, people who sustain chronic ketosis or very, very low carbohydrate diets, where they're maybe not even aware that they're actually, if they're not had any health problems, that they may actually be easily always in ketosis. And perhaps that may be a natural state. And if it is, that should be our baseline. So when we take a group of people who have cancer or Alzheimer's disease or cardiovascular disease, and we do a controlled intervention, you take a group of them and get them to go into ketosis, and have another group who are your control, who don't have that intervention, who are the normal population, let's say. Now, that is one way of comparing the changes that come out from the intervention group being put in ketosis. But I often wonder, is it correct to be comparing them to the group of people who are also not in ketosis? Because maybe that's not necessarily the best parameters to be comparing against. If we're looking at pathological conditions, then putting people into ketosis, then would we not want to see their trajectory of their changes to be more similar or in the direction of people who are really healthy, never had a chronic disease, and also in ketosis? And so this is what I thought, we really need to investigate. So then I conducted a pilot study. So it's a feasibility study. It wasn't designed to be powered for statistical significance. And I chose to study... Ultimately, I am studying both males and females, but this particular pilot, because I had only the ability to conduct it on such a small population, then of course I wanted it to be as homogenous as possible. And so I had 5 females. It was all females, and the age range was between 23 to 37, 38, premenopausal, no prior metabolic health conditions at all, and the requirement was to have been more than 80% living one's lifestyle in ketosis for a year. And it just turned out that actually it was no less than 2 years in this group. So they really were really chronically keto adapted, which is quite fantastic. It's quite a commitment. The study took place over, the baseline measurements were 3 weeks long, 21 days. And then we had a lab day when the participants come in for blood works, tests, and anthropometry. And then the intervention was 21 days. Then they came in the lab again. And then they reverted back to their lifestyle for another 21 days. So there were 3 phases. And in each phase, they had to take their finger prick capillary test, blood, ketones and glucose. And they had to do this 4 times a day, spread through the day, when they wake up, when they go to sleep, before lunch if they had lunch, and before dinner if they had dinner. And the intervention was to suppress ketosis, and following the UK Eat Well guideline. And really our marker of compliance was, are you in ketosis during the ketosis phase, your baseline, demonstrating your lifestyle compliance, and then afterwards when you revert back to ketosis after the intervention. And the intervention being to suppress ketosis, so to have no ketones present in your capillary blood following the UK Eat Well guidelines. One of the main things was we made sure that it was an ad libitum study. And you always hear in these kind of studies that you hear that well, it was not calorie controlled, and dietary studies are inherently very messy and difficult, and this is in somewhat not a dietary study, even though it was a dietary protocol. You could say that probably it absolutely affected being in ketosis or not, although obviously you can eat carbohydrates and still be in ketosis if you time restrict your feeding, or if you intermittently fast, if you run a double marathon, these sort of things. But what I understood from a lot of studies was, if you control for calories, you are actually inadvertently affecting hormone signaling, because you're overriding what that food source does to your satiety, what it does to hunger signals, which are hormone signals, ghrelin, leptin, adiponectin. These are hormones that really affect your feeling, your sense of, do I feel full? Do I want to eat more? These hormones, those hormones have more effect on more hormones. And so by controlling for calories, you're not allowing the natural effect of those food sources. And so ad libitum, one can argue that, well, we don't know how much of this had an effect, how much of this, because as scientists, we are a little bit obsessed with, we keep everything the same and we change one thing. And I think that, of course, there's a strong value in doing that. At the same time, we live in the real world. The real world's a little bit messy, and people are different. We like to eat at different times. We like to sleep at different times. Some people eat their food in 5 minutes. Other people like to take 55 minutes, and it has so much different effect on the body. And we're not controlling for having multiple triplets. The people are different too, and in physically, genetically. And so to allow people, and ultimately when it comes to, for me, I'm not saying you have to eat, whether it's vegan, vegetarian, mixed, standard UK, paleo, carnivore. It's not like this. For me, it's an interest in what's your metabolic phenotype, and how you as an individual can learn to understand how your body reacts to things, and how you can then assess that and make the adjustments. It might just be small adjustments, it could be large adjustments, but make the adjustments that are sustainable, pleasurable even. That's really important. We always hear people talk about it's really hard to cut calories, or it's really hard to fast, or it's really hard to give up certain food groups. There's actually a multitude of ways that you can modulate and adapt things in your lifestyle and still actually have those pleasures, or find a way that just works for you. Most importantly, I think, with regards to gaining good health, it is an effort. It is work. To get good things usually is, but it doesn't have to be a chore. That's the difference. And so no one wants to feel hungry all through the day. No one wants to have this brain fog or this constant nagging behind in their mind, and to have a grumbling feeling in your stomach, or to feel low in energy. That's not good health. Those things in themselves are not a good sign of health. So if a form of lifestyle, likely dietary part playing a huge role, is causing you to feel like you want to chew your nails off, or causing great anxiety because you have to count calories, let's say, or count what, these sort of really control how much you eat on your plate. This I would argue is not sustainable, and it's not health either. Health is in your mental well-being. So how you approach what you do in your lifestyle to gain the best health you can, and the psychological impact that has on you for you to be able to continue with that, it's really important. So the methodology, if you've chosen it and it doesn't make you feel good as your well-being, then you have to start to assess, is that a good approach? And the reason why I say this is because, we have had 40, 50 years of people essentially trying to lose weight as the most obvious one, but always assuming that weight is the cause, let's say, of a lot of pathological conditions. So they think that we'll cut calories and exercise more, but they feel absolutely awful in the process. I would argue that plays a role in the non-sustainability. And ultimately coming down to the women who were in my study, they followed ketogenic diets, but it was very interesting. They each had very different ways, and they actually had, because they were healthy women, they had different tolerances to carbohydrates and vegetables and meats. It was absolutely fascinating. It was fascinating to see that some could have a high amount of dairy and yogurt and stay in ketosis, and others couldn't. And some of them could eat a lot of broccoli and broccolini and have no problem, and others couldn't. And not that these were interventions, this was their own awareness, because they were testing 4 times a day their capillary glucose and ketones. They obviously understood themselves really well. And so the study was very, very fascinating. And one of the reasons why we are interested in ketones and blood glucose, a lot of people just think, well, I just want to have presence of ketones, and that's it. But how does that tie into insulin? Exactly, what's that? Because we're not testing insulin here, but we do in the laboratory when they come in. But what it really is that people know that insulin puts glucose away. What they're not really aware of is insulin does so many more things than just help glucose go into cells. And in actual fact, a lot of your cells in your body, glucose can go in with absolutely no need of help from insulin. And so it's not the only role. When the sort of, let's say, medical and health establishment have focused so much on glucose, that when we see glucose in a pathological concentration, and you realize that that is unhealthy, but focusing in on glucose makes you think, well, then health must be a normal glucose number, no matter how we got it down. And that's a really big problem, because then the paradigm becomes insulin or other drugs to just get it down. And therein lies a lot of the development or increased cases that we have of chronic diseases. So I believe, and so it seems like when you read in the literature. So insulin is an anabolic hormone, and it is life essential. So you have to be cautious not to sort of then suddenly think insulin is this big bad, evil, horrible hormone. It's not. It is absolutely life essential.
But you can have it be too low as well as too high, can't you? So
absolutely. I mean, type 1 diabetics, there's this insufficiency. And this is where this word insufficiency can be difficult, because some people who see elevated glucose, whether it's type 1 diabetes or type 2 diabetes, they go, well, you just are insulin insufficient. You need more to get that glucose down. So it is important to distinguish between the two. And if there is a problem, you have to investigate to find out, sort of, are you genuinely insufficient, or are you actually producing too much, which is hyperinsulinemia. And even in an insufficient condition where you may not produce enough, and certainly it needs investigating the health of the pancreas and the rest of the body. But in that case, if you don't produce enough, the better thing is to cut the thing that you bring into your body that elevates your glucose to need so much insulin, to sort of give your pancreas a rest, that it can potentially heal itself as well. But in the case of hyperinsulinemia, you can have very healthy glucose numbers for quite some time, because you've got a pernicious, hidden higher level of insulin, and it may not be some crazy high level, it's just a little higher. So it's still within what we would call the reference range, even though there really isn't a good reference range for insulin. And so it's very pernicious. So this can be going on for years. And what we actually do know is that you can be hyperinsulinemic for up to 24 years before you become hypoglycemic. That's incredibly pernicious and chronic, and it's very hard to take action on health things when something has that long of a duration that you don't necessarily think, oh, I'll just worry about it later. Especially younger people, you know, 18, 19, 21, 24, you're not thinking about what's happening in your mid to late 30s. But unfortunately, it is having quite a profound effect. We're seeing a lot of the chronic diseases that we would associate with aging, the first being type 2 diabetes. It used to be called adult onset. The age of cancers, a lot of cancers, they're coming younger and younger and younger. Alzheimer's coming younger and younger and younger. And these conditions have been strongly associated with hyperinsulinemic, insulin resistance, hypoglycemic condition. You know, they've come in this family. So the thing with insulin, even it's natural signaling method, but it's anabolic, and so it controls these pathways, and hormones in the body have this hierarchy of which ones sort of have the drowning out effect over all the other ones, let's say. And insulin is at the sort of top of the hierarchy of signaling molecules in the body, and hyperinsulinemia can really sort of set off a cascade of things in the body that essentially change homeostatic sort of feedback loops, because the body's really all of these feedback loops. You know, your hypothalamus triggers something in your thyroid, triggers something in your adrenals, triggers something back up your hypothalamus, and they sort of go in this circle. And you'll find people who are hyperinsulinemic, a lot of these loops are not working. They're broken, so to speak. So, for example, the parathyroid hormone would normally signal to the renal system to upregulate vitamin D, and FGF23 would signal to downregulate FGF23. And you wouldn't expect to see high parathyroid with high FGF23 at the same time, because they're obviously working against each other. And a lot of hyperinsulinemic conditions, you'll see both of these elevated, and you'll see vitamin D low, which means the parathyroid hormone is not working. And so you see when you want to assess someone's health, it's never a good idea to look at one marker and whether it falls inside of a reference range. You want to usually have a look at a triage, if not more markers, and how that triage works together to let you understand what's really going on in that system, in that feedback loop. And then you can actually really understand, there's something going wrong here because the feedback loop's not working.
In your study that you did on these women, you had 5 participants?
Yes. Yeah.
Did you find anything interesting in regards to menstrual cycles and blood sugar levels, and even just were you measuring satiety and mood and these kinds of things, along with you mentioned metabolic markers? I'm just trying to assess what things you were measuring and what you found, particularly around those periods before menstrual cycles.
The participants recorded quite often. They recorded how they felt. They also recorded. We had 3 mood questionnaires that were from the WHO, the NICE, NICE, and from the NHS to assess their emotional disposition through the phases. And then they also recorded bowel movements. And there definitely was a pattern in terms of cravings, much more cravings at certain times of the month. One of the things, it may be unique to this group of individuals, because, you know, to choose to live in a lifestyle that essentially keeps you in ketosis, you know, you could say is a special group of people too. No different to people who choose to be vegans or vegetarians or carnivores as well, you know, one could argue. And this group were they were, let's say, not homogenous with regards to some were much more vegetarian than the others. So this was interesting because they all managed to sustain ketosis very well as well. But there definitely seems to be less cravings, when the women were in ketosis. Now, these are just observations because it wasn't our study to focus in on this. It was more we wanted a detailed daily report, just how they felt, you know, all of these sort of little things that you know, that is much harder to analyze. But it was very interesting to learn about these things because it was a feasibility study. We wanted to see what, you know, were the things that we were missing or not. It just so happened that all of our participants themselves were scientists, and so it gave us a unique ability that the participants were able to data log in a lot of detail, which obviously is absolutely fantastic. We measured, when the participants came into the labs, we measured over 44, or it was actually a bit more than that, blood biomarkers. So we measured a lot: fasting lipids, metabolic parameters, thyroid hormone, white blood cell breakdown, antibodies such as antithyroid antibodies. We also ran an OGTT, oral glucose tolerance test, with an insulin sensitivity assay, and we also put the participants on a bioelectrical impedance to measure lean body mass, fat mass. We made sure to keep the raw data in terms of electrical conductance through the body, and we also had the participants under a respiratory hood, which was the Quark Cosmed, to assess their respiratory quotient and resting energy expenditure. So it was quite a lot. It was a very long day. Participants would come in at 7:30 and they would pretty much leave around about 4 p.m. So it was a very long day on the participants. And then, of course, as those of us who work in the lab. So but we were able to really analyze participants and really look at, and one of the things is that the dynamic responses they had to the oral glucose tolerance tests and their insulin assays that came with it was really fascinating, because it was very, very homogeneous in terms of within the group, within each phase, but also between each phase. So the coming out of ketosis, the intervention of suppressing, and then the returning back to ketosis, the graphs, the curves of the dynamic responses were very, very homogeneous, which we didn't expect. With 5 participants, you can't, no one who's a scientist thinks that 5 participants is going to reach statistical significance. And so it was very, very interesting to see. We had normal distribution with regards to the numbers that meant we could, let's say, feel more confident on the strength of the statistical significance. And we did see statistical significance in our markers of interest, which was really a bit, let's say, crazy. Still, it was a feasibility study, and so we're going on to do a larger study to essentially, in some degrees, refine the study and repeat it, because even if you have many other studies, a lot of the time, a lot of studies are not repeated, of course, because they cost a fortune and they are time intensive and they require a lot of people involved. But part of my PhD study, that was a pilot, and so I'm going on to do the larger study, which should improve on the first one. But ultimately, actually, it is the testing hypothesis of, is that true? Let's test it and see if it comes out the same or not. So, yeah.
What were the most interesting things that you found, just in terms of even individuals? Was there anything that anyone with really high readings, or something that seemed unusual where they had more carbs and they had low blood glucose, or anything like that?
Well, I think something that you could argue is obvious, but maybe not so, is even being in ketosis, not sleeping well had such a profound effect. Not going to sleep, at a, I'm not saying early hour, but going to sleep ridiculously late and waking up really early, increased blood glucose by so much. It was really quite incredible. And then exercise was an interesting one, because there's a few things people would have expected. I'd wake up with lots of ketones, and and what we saw in our participants is they tend to have lower ketones in the morning and higher ketones in the evening. And if they exercise, their ketones would really sort of drop off by a lot. And what that really, and they were in ketosis, they measured, a lot of my participants actually measured more than 4 times a day to try to really understand what was going on. And, it's understandable if you are in ketosis, and arguably if you're not in ketosis and if you have any ketones still, then you would use those ketones. They are a fueling source. They're more than a fueling source. They signal to your cells and essentially tell the cells the energy status and the metabolic status of the body. So they're doing more than just providing a fuel source. But exercise, arguably, of course, if you are in ketosis, then you would be burning a lot more fat, and maybe making it so that fat's not available to be turned into ketones as well. That may be the case, but we certainly saw this consistently. The participants learned a lot about themselves, and they learned there were certain food combinations that would ramp up their ketones, and certain food combinations that would not, wouldn't necessarily massively lower them, but wouldn't ramp them up either. And the participants, one of the things you could say was quite homogenous between them is that they would drink tea or coffee, usually coffee, through the day with a lot of double cream. And a lot, some of it was calculated to figure out how much exactly. And so, that's obviously playing a role in satiety. You wouldn't necessarily call that calorically fasted, although we could call it metabolically fasted in the sense that it's a fasting mimicking diet. And these women were busy working days, so they were able to plow on through their day. They didn't missing lunch, because they didn't have hunger. They sort of felt ease to go through the day. And when they were out of ketosis, they all commented on feeling bizarre to feel hunger again. They had literally forgotten what it felt like to wake up in the morning feeling hungry, and to have that stomach, whether it's pain or growling, and that empty void feeling. And so they did comment a lot on this. They commented a lot on the much higher frequency of bowel movement in a negative sense. So they had less bowel movements when they were in ketosis, but they were, let's say, non-events, easy. The bowels seemed to work, just they didn't need to go to the bathroom as much, which was actually nice. And they said that when they went out of ketosis, and this was recorded and documented, there were a lot more bowel movements that were also not necessarily easy as well. So these things are important to note. Although I have a lot of data on what the participants consumed, ultimately, like I said, it's not a study on an intervention using food per se, as in some of the participants actually even ate carbohydrates during the ketosis phase. It's just that they tend to time restrict when they're eating. And so
that makes a huge difference, I find. And even the amount of calories consumed and daily activity and sleep, like you mentioned, and even your state of mind.
Yeah.
Me personally, I find that I have this routine where I go for a 2-hour walk every morning, just as soon as I wake up, just a fasted walk. And I find that when I come back home, if I measure my blood ketones and blood glucose, the levels go right up. But before the walk, I'll actually have a slight increase in blood glucose from the evening before. Yeah. So that walk has a huge benefit for me personally. And even sometimes before I go on the walk, I have this, because I have epilepsy, a type of epilepsy that's called reflex epilepsy. I always have this slight seizure activity throughout the day, but that can vary quite significantly depending on my blood glucose levels. So I don't usually, it's not all about the ketones, but for me, it's more about the stabilizing that blood glucose. So what I find is just that if I do any other kind of exercise, anything that's more intense, that can actually trigger a seizure for me. But if I go for these long walks, I guess that's actually decreasing the cortisol. And after about half an hour, I get this kind of euphoric feeling in my head, and my symptoms completely go away. So in the morning, I can often wake up with this slight seizure activity, sometimes some focal seizures. But I'll force myself to go out for this walk and just focus on my breathing. And then, yeah, after about half an hour, it's just like a cloud that lifts, you know. Feels like my head's in a cloud, and it just lifts, and then I feel like I have a ton of energy and I'm very mentally sharp, and it's like a complete change.
It isn't all about the ketones. This is absolutely true. And of course, I say that where it depends on one's health status and what you're trying to achieve. So, you know, it's not so black and white. But my interest in the presence of ketones is because of what it tells you about how much insulin is around and how much insulin is needed to facilitate glucose regulation as well as ketone regulation and production. And so what I see ketones a lot as is a marker of, is your insulin at a level that's not pathological for you? And so if you can find on a papillary meter that you have ketones and your glucose is at healthy range, then this is essentially saying that insulin is most likely at a non-pathological concentration for you. And it is kind of the triage of the three that really tells you the bigger story. And as you said, you know, with regards to sleep and stress and how it affects your cortisol levels and then how that subsequently affects the body. I mean, you know, glucocorticoids, you know, I found out, I've been working on a project that is just really fascinating recently, but how the bone cells play a huge role on glucose metabolism and therefore insulin regulation and sensitivity, which therefore will then again affect how well you can burn fats and how well you can make ketones to be able to use them, because insulin regulates the ability to make ketones. And so they directly, it's a rate limiting factor. And so that's why insulin is so important. And although we don't have a home way of measuring, and even if you did have a home way of measuring insulin, we don't actually really know what's the right number, because it seems to be so different between people. And the thing that lets you know what seems to be the right number is, unless you are type 1 diabetic, insufficient on insulin, it's that if you produce ketones in a normal glycemia, healthy glucose range, then whatever the insulin number is within that is at a level that's non-pathological for the person. And so you can kind of almost, it would be nice to know what that insulin number is, but by itself, it means nothing. And it may actually change depending on your age, your sex, your menstruation cycle, any of these things. But having normal glucose, presence of ketones will effectively, they are proxy markers for letting you know that your insulin is not at a pathologically high number. And the thing is that glucose is a fueling substrate. So are ketones. Both of them are signaling molecules as well. Glucose, the body senses it and it tells the body something. Fatty acids, the same. But insulin has a unique position in terms of how it is telling cells to grow and divide. And insulin is the sort of cell, that sort of signal molecule that when there's a lot of it around, it's essentially a kind of message that it's telling cells, oh, you're fine, there's like so much food available, there's so much, don't even recycle your stuff, just keep going, just keep building, just keep dividing, it's all good, you've got plenty of stuff. And so there's less quality control, you could say. There's less quality control in the process inside the cell, because when, let's say, there's abundance of a signal that is telling you there is abundance of everything, then there's no need to recycle and keep a tight ship and to keep things clean and to repair broken things. You've got something broken, just shove it to the side and let's just keep going and build something else. And if it's a bit broken, it's a bit faulty, who cares, you know? It's kind of this mentality, and you start to get this accumulation of not quite 100% functioning molecules inside of cells. And that can go by for a long time. The cells can still get by. There's so many multiple redundancy processes, backups. But ultimately, it starts to catch you out if enough cells go through this, enough so that a tissue starts to not function so well, or that enough cells start to transform. And when we say transform, they're really not behaving in a way that fits with the tissue that they come from. They now start to uncontrollably grow and divide, and this is what we consider to be tumorigenesis. And so they have this phenotype that changes of uncontrolled growth and proliferation, and insulin really sits at the heart of a lot of this, although again it's also partly glucose, it's partly other things too, but insulin really, let's say you can control glucose two ways. You can control it by how much you bring in from your food. You can control it to some degree by how you manage your stress and your sleep.
Even how you breathe, I find.
Absolutely. And then glucose is going to stimulate insulin secretion. Stress can stimulate insulin secretion. There's a lot of things that can stimulate it, but there's, again, some things have a bigger impact. We all eat, we all need to eat. It has one of the biggest impacts on insulin secretion. I am sure that sitting in front of TV, watching cakes be baked and things like that causes you to produce insulin.
Even just sitting down for too long, I think. That's why right now I'm standing, and I try to stand as much throughout the day, just limiting my time sitting down. So
movement, and I'm not talking about exaggerated exercise movement, but movement,
low level activity. I try and get as much low level activity as possible throughout.
Exactly. So this idea of getting up from a chair, standing up, sitting down, getting up frequently to go and make a tea, walking up and down the stairs. It's the regularity. It's not about one once a day intensive exercise and then the rest of the day you're just sitting sitting at a computer, let's say, but the frequency seems to have quite an impact, and it has an impact on many areas of the body. But one of the things that I've come to understand is its role on maintaining the health of the cells in the bones. And the bones, we all often just think of bones as these sticks in the body that just hold everything up, but actually, they are where our red blood cells are made. They're where our immune cells are made. And in actual fact, not just that, the bones themselves, they are made up of, the minerals, calcium and magnesium, but also hormones such as osteocalcin, such as FGF23, sclerostin. There's these hormones, and osteocalcin is a really important one. So really healthy people have quite high levels of osteocalcin, and people who tend to have metabolic conditions, who are overweight or not overweight but have cardiovascular disease, chronic kidney disease, type 2 diabetes, they have lower levels of osteocalcin. And osteocalcin are produced by osteoblasts and osteocytes. So obviously you would need to have healthy osteoblasts and osteocytes to produce enough osteocalcin. And a lack of low-level movement, sort of a movement that sort of resists gravity, going from a sitting down to a standing up position, those kind of things, going up some stairs, this sort of resisting gravity movement, which even walking would be doing, decreases their survivability. So their health is dependent actually on this movement, and this movement is predicated on gravity. And a lot of research is in this in terms of microgravity for astronauts. And so the importance of this is, how does that come into it, is because osteocalcin affects glucose sensitivity. It affects insulin sensitivity. It affects glucose uptake, insulin sensitivity. It affects the uncoupling proteins in your fat cells, which comes down to, heat therapy, cold therapy, wanting to have more uncoupling proteins. That increases thermogenesis. And so this is kind of, you increase thermogenesis, you're kind of losing weight without doing any extra effort. Just means you burn off essentially calories easier. But there's other things. The osteocalcin increases skeletal muscle mitochondrial biogenesis. And so it's not, though, I think the danger, again, like when we see that healthy glucose numbers, if we have that as a target, if we say that we see people who are healthy have healthy glucose numbers, therefore you end up using more insulin just to get a healthy glucose number, which doesn't turn out to be a healthy outcome. And it's the same with osteocalcin. There are studies where animals have been given osteocalcin and improved their health, but those animals were healthy, so they could have that. There are also studies where not so healthy animals were given, so these animals were on high insulin stimulating diet, so it was both high fat and high carb together, which was a high insulin stimulating weight gaining diet. And those animals were given osteocalcin, and it actually was pathological. They got worse. They had decreased their insulin sensitivity. And so this shows us that there is the role of what osteocalcin does, but also which cells it comes from. Clearly, it means we need to maintain the health of the tissues and those cells of where they came from, so they can then provide what the body needs in that respect. And so when we talk about exercise, this is where the movement, rather than an actual going out and doing sports, which of course, arguably can be really good for you, and most often is, but just in terms of low level movement, it's absolutely fantastic. And we have a system in society now where we sit for long hours on our computers, and not us, our children in schools. We teach them that to study, you need to arrive at school and sit at your desk and spend many hours through the day sitting. And, I think that we've drilled it into our kids to be able to sit down and focus. But maybe when we see that children don't naturally do that, maybe it's because that was not the best natural state for humans and children. And as much as education is very, very important for them, and we need to help them receive a good education, there is a bit of a problem in the sense that that education comes at the expense of their natural, much higher amount of movement they would normally do.
I also feel like people undervalue walking as a form of exercise.
Yes. I think
if you're walking every day, you can do it every day. It's not stressful. It's not a stressful kind of form of exercise. You could go for a long walk, and you're using fat as the primary fuel source. You're also getting all these other benefits, the cognitive benefits, and just mental, just well-being. So
it's a bit of a timeout, isn't it?
Yeah,
it's actually a bit of a timeout.
And it helps you to be more creative if you want to do writing, or if you've got some stressful thing you're working on. I find that it just clears the mind. And
this is one of the things that you had just mentioned, which is you burning fat when you're walking. And I often do mention this to friends that when people who are not in ketosis, when you exercise, people who are not in ketosis, they sort of know that, well, you have to exercise for a full 40 minutes before you're going to start gaining any benefit. And then when you ask, well, what's the benefit? And they're saying, well, in the first 40 minutes, you're burning glucose and glycogen, and you want to burn that off. Now, that might be 20 minutes in some people and up to 40 minutes in other people. And then the idea is that after you've burnt off as much glycogen as possible, then you start kicking into fat burning. And so goes the sort of penny drop moment, in the sense that, well, if you want to be fat burning, you're saying that fat burning is good for you, right? The ability to burn fat, the metabolic flexibility. Again, it's not to say that burning glucose is bad. It's not to say that, there are times that may be good to be using glucose and even adding it into your diet. It's really a lot to do with your intolerance level, what your lifestyle is, and what your health position is at that time. But it is, let's say, it appears that being able to easily get into fat burning really strongly associates with health, that metabolic flexibility. And yes, when you're walking, if you are already metabolically flexible, or you are eating a very low carbohydrate diet, or to the point that you are in ketosis, then you're going to be burning more fats. And when you burn more fats, you're not just burning them, you are sending signals in the body, as the body gets signals again. And one of those signals is the cell sees that it has to burn fat. That's number one. Number two, there's a sort of spillover that it can't keep up with the burning of the fat, and then you get ketones that are made. And the cell sees this as, okay, so this is the fueling source we have. We have to make more of the machinery that burns fat, which means make more mitochondria. Because mitochondria are the major source of reactive oxygen species, with that signal, in terms of burning beta oxidation fatty acids and ketones, it also sends a signal to the nucleus that we also need the management team for ROS, for reactive oxygen species, which are the antioxidants. So you get more intracellular antioxidants. So a lot of people sort of think, I want to eat this food because it's full of antioxidants. I want to eat this supplement because it's full of antioxidants. And the body is actually very good at making antioxidants if it's in the right state. And so when you do things like exercise or go for long walks or sleep really well, eat the foods that don't hyperstimulate insulin secretion, and that puts you in a position that you are better able to burn fats, then your body becomes also better at making its own antioxidants that are inside of the cell, that are directed exactly where they need to work, and finding that essential sweet spot of having enough antioxidants that it's managing the reactive oxygen species that often need to be produced because it's a signaling molecule, but not too much, because the body is based on this harmony of oxygen species and antioxidant species. It's this redox, and it can't have no oxidation. Those oxidant molecules are signaling too. And so an obsession with taking too many antioxidants, or let's say consuming foods that one considers to be super rich in antioxidants to the point that you consume tons and tons, could potentially be dampening that signaling that comes from oxidation, such as inside the stomach, inside the intestines. The immune system is very active in your intestines because your body's being exposed to external microbes and foods, and so the immune system is checking everything, and it needs to be reactive. It needs to be slightly inflamed, let's say, or an ability to inflame, to make sure that you are safe from what you're eating. And it could be, to some degree, the excess taking of foods that are considered hyper concentrated in antioxidants and supplements could dampen that effect. And I say it with caution, of course, because I think that everyone is best positioned to really sense what works for them. Your feeling of well-being, rather than looking at biomarkers and all these sort of things, start to look at how you feel. Do I feel hungry? Do I feel tired? Do I have focus? Does my digestion feel uncomfortable? Am I able to go to the bathroom with ease? All of these sort of things are really good markers, actually, of whether this setup that you have works for you. So hence why some people take supplements and it seems to work for them. Some people, there are definitely clear indicators that certain supplements don't work for them. The same with regards to vegetables and not vegetables, things like that. But one of the things I do try to focus on is that we can't just look at antioxidants as something that we need to ramp up and take into our body, because you can also dampen a necessary oxidative signal. And so this is where the body is actually intuitively more fine-tuned at managing it correctly. If you get yourself into a fat-burning state and you can flex between fat burning and glucose burning in some respect, your body is then able to modulate exactly the amount of antioxidant necessary so that you still have the oxidation signal for that to tell the body other things, such as build more muscle, build more bone, repair things, because that needs this oxidative species to send that signal. But with that oxidative species, you also need the other molecules to come in and go, okay, that was just enough, now let's turn it off.
I feel like so many people don't understand that whole thing about the antioxidants and endogenous antioxidants. You get people who will be taking intravenous vitamin C and they'll be telling you that it's a powerful antioxidant, but it's a pro-oxidant treatment. It's just things like that. Just
it's difficult because you can, I was once asked by my director of studies what was my stance on vitamins, on antioxidants, vitamins, and I said, well, as a scientist, when we look at the sum of a lot of research, quite often when you pull research, you can end up with no signal at all, a lot of noise, and then something can look like it has no effect. Because when you start to get so much noise going along, it sort of dampens everything out. And I like to just try to apply some logic. And I say, well, we know that people who have scurvy, if they take vitamin C, it goes away, right? So that's an example of clearly supplementation with an antioxidant, ascorbic acid works. We know that with regards to spina bifida, taking B vitamins when you're pregnant will prevent this. But it does get more complicated. It does, your health status and things like that. And vitamin C, whether the vitamin is an oxidized version or or reduced version, I would argue that people who do consume high carbohydrate diets benefit from vitamin C. Now, I say that
protective.
Yeah. So there's that nuance again, in the sense that it's possible that depending on your metabolic state, this exogenous supplement will have a certain effect. And remember, we've got so many studies where we don't know if those people were in ketosis, not in ketosis, high carb, low carb, or exercising a lot, not exercising a lot, all of these sort of things. And so that's why it makes it very messy and hard to understand. Vitamin C is an interesting one. It is something that, if we sort of have a look at the Inuit, they clearly don't take vitamin C supplements. They're clearly not eating lots of fruits and lots of vegetables. And they do, in the traditional Inuit, not obviously ones who have had a lot of contact with Western civilization and now sort of progressed into a lot of interaction with our communities. But when you look at the traditional Inuit, they were well known for not having cardiovascular disease. And vascular disease, the word vascular being important, because vitamin C plays such a heavy role in the vascular system. It's the production of collagen and the fibrillar connective tissue. I mean, what do we see with scurvy? We see the breakdown of connective tissue. If you have bleeding gums, this is something wrong with the connective tissue in your body, and that's reflective inside of your body too. And so we look at vitamin C playing this role. Now, the thing is that vitamin C doesn't necessarily directly play this role as a direct molecule on redox systems. It also plays the role in the production of these connective tissue molecules. And so with regards to the Inuit not having a high vitamin C diet, that's also because they have a diet that's high in the final product of what vitamin C is trying to help you make. So it just means that you just need less vitamin C for them in their situation. And one can argue too that they may not be having a dietary lifestyle that also depletes vitamin C much more out of the body. What we can say is that being low carbohydrate to the extent of being in ketosis, it increases recycling of vitamin C. So inside of the mitochondria, there's a molecule that's called glutathione, and if you are in ketosis, it upregulates glutathione. It regulates the gene transcription, so you have more of the basic molecule, and it also upregulates it being reduced, which means it can then do the job to recycle vitamin C. So again, it means that you don't necessarily have to take in as much vitamin C. It lowers your need to replenish it, and you're also not wasting what you have. So this is that sort of difficulty in terms of, does vitamin C always work? I mean, if you're perfectly healthy, let's say, and you're low carb or in ketosis, or you're metabolically flexible, then it may be that you take vitamin C and you don't see any difference whatsoever in that respect. And then someone who has intravenous vitamin C may feel and notice an absolute difference. Maybe they really had a lifestyle that was really depleting them, not just of vitamin C, but of the final products that vitamin C is trying to help them make in this respect.
There's definitely that difference between having it from a dietary source to having it intravenously. Just intravenously, you're able to have so much more, and it just, I don't know exactly mechanisms, but it seems to have much more of a noticeable effect.
Yeah, I mean, of course, when we talk about consuming it and then injecting it into the bloodstream, it is going to have a big difference. I mean, for anything eaten, it has to go through quite a process to get into the body, right? And the stomach acidity, the level of the acidity, that's going to have a role on not just digestion, but absorption, whether certain minerals or vitamins become bioavailable, how much passes through the stools, how much is absorbed in and goes to the liver and then just gets detoxed out or used up by the liver, all these things. So yes, there is this argument that there seems to be more effect with an intravenous application. Yeah,
I have lots of cancer patients who are female who ask me questions just about why they're struggling on the ketogenic diets, and why their blood sugars aren't doing what they want them to, despite eating a very strict diet and even limiting their protein at times to ridiculously low levels, and
Yeah.
all these things. And sometimes I can give them an answer of why I think it is, but not always. Sometimes it's not always immediately obvious, and I'm thinking, well, I don't know what the answer is, but then also I'm not female, so I just find it, I tend to think it's a lot easier for males. I don't know if that's a generalization or if that's actually born in fact.
Well, it's, I would say that I've noticed with women, in general, women are a lot more sensitive to cheese and yogurt. So I don't say dairy, because then they seem to be okay with butter and ghee like this, but cheese, yogurt, and milk. These three, which in a non-pathological health position, I would always argue that cheese, healthy cheese, in terms of, like, you know, a good quality cheese, is healthful.
Is there a difference in cow or sheep, or, you know, A1 versus A2?
Well, it depends what you're looking for. It depends what you're aiming for. You know, are you looking for a cheese that's got a large bacterial profile? Are you looking for a cheese that's rich in vitamin K2? Are you trying to avoid cheeses that are rich in glutamate? You know, so it really sort of depends on, are we just talking about cheese in terms of the flavor, or are we trying to see it as a nutrient source? And then you might want to be more discerning about what you're trying to get from your cheese. But you're talking about women who have cancer, and so it starts to become a bit more nuanced, and what that is, you know, as you know, cheese can be very high in glutamate, which is an issue for people who have cancer. And it is a difficult one to get into, because there's a lot of good research showing that high quality, unpasteurized, obviously well kept, so that, you know, you're eating unpasteurized foods, but in a natural context, historically in France and Italy and other countries, they don't have food poisoning problems because the source is a good source. But unpasteurized, good quality cheeses, one could argue, is very contribute to avoidance of having cancer. It contributes to good health. But if you have cancer, especially after, you know, in more of a late stage 2, 3, 4, stage 4 cancers, then, you know, you really need to be fine-tuned on everything. And that is part of the being really careful with glutamate, which is used as well as glucose for aerobic ATP production, and so this is something that not a lot of people focus on. They focus more on glucose used, cancer cells using glucose, but they're not really focusing on glutamate, which is often used, and cheese can be very, very rich in glutamate. But for women in particular, I mean, ultimately we know that milk, dairy, it's for growing little babies. It's a growth stimulating food. It's the perfect combination. It's, you know, human breast milk is ketogenic, but the baby still grows even on a ketogenic meal. And that's because the types of protein, the casein and the lactose, the combination, these sort of things, is telling the body to grow. That's what dairy foods do. Now, I caveat butter and ghee out of that, because we've sort of removed a lot of that out of those two products. So women, I always say, if you're struggling, do cut these out. Modulate it at the very least. I don't say if they have cancer, it's different, but if they don't have cancer, I'd say, because cheese can be so healthful, maybe only have it once a week or twice a week, or maybe be aware at the time of your cycle when there's definitely a time of your cycle you crave more and you easily gain weight more. I mean, it makes sense. The body wants to get pregnant. The body wants to be able to have a baby. So there are times in a woman's cycle where it's like, you know, instead of taking on 80% of what you eat in terms of absorbing it, the body takes in 90+% because it's gearing itself up to be able to procreate. So for women, there are these things. There are other things. So certain foods seem to play a role on things like your thyroid. And so there are a lot of the time, and this will be the same with cancer patients, and there are a lot of times certain vegetables that, and I say vegetables, that seem to increase an autoimmune response. And it's not a blanket I know people who can eat all these vegetables and be in superb health. So you need to find out for yourself. And, you know, the knowledge that we have so far is that it comes down to two things, not only, but they seem to be flagging, which is the lectins and the oxalates. Now we know oxalates accumulate in glands like the thyroid gland, and so oxalate-rich vegetables may be playing a role. Lectins have been shown, certain lectins can stimulate insulin receptors independent of insulin. So that's in some ways, I always think that's a bit wacky, you know, that wait a minute, I'm not eating carbohydrates, I'm not injecting with insulin or taking any medication to stimulate more insulin, and yet those receptors that I don't want signaled outside of that are still being activated, and that's because of certain lectins in certain vegetables. And I definitely have noticed certain things like aubergines, tomatoes, kale, spinach. These are sort of high flagging vegetables in that respect. And I don't want people to suddenly start thinking these are awful foods to eat. It's just a question of figuring out, are they working for you or are they not working for you? And sometimes I've even found that some people just cut them out for a while, not for a long while even. They just cut them out for a while, get themselves to robust health. And I'm a big believer that the sign of a really good body is you can tolerate things. You can bring things back in because your body's now fixed, it's now healed, it's now stronger to face those challenges. If you've got an injured knee, let's say, you're not going to go for massively long walks that are going to traumatize your knee more. It doesn't mean you're never going to be able to walk again. It's just that you need to get your body and your knee back to good health and good strength, and then you can face that challenge in life again. And it's often the same. But again, for some people it's not. For some people it's like, nope, you know, I can't have it at all. And other people, it's a relief. Oh my gosh, that thing that I've always been suffering, that thing's always made it really hard for me. Now I know what it is. Oh, and to not have the pain, to not have the problems that they have. With regards to, so with regards to women with cancer, they've got these aspect cheeses up on there. Obviously vegetable oils, a lot of people unfortunately have taken on board and being very compliant with health guidelines, which suggests that, you know, one should avoid animal fats and should have vegetable oils. And even those who go in a ketogenic diet, there's still a lot of caution. And so there's this sort of, okay, well, I won't eat a lot of animal fats and I'll eat olive oil instead, because that seems to be a sort of neutral. But if you are consuming a lot of olive oil, it's not to be negative on olive oil, it's just that it means you are consuming less of the other fats at the end of the day, because there's only so much you can consume in one day. And a lot of these other fats, these animal fats or animal product fats, such as from butter or ghee, or non-animal, such as from coconut oil, they contain a variety of different kind of fats, and those fats have signaling roles again in the body. And in some animal fats, they contain omegas, and they contain other things like fat-soluble vitamins. And people will argue that, well, it's, you know, as a percentage per 100 grams, it's very low versus something else, let's say of a plant source. But ultimately, it's how much are you getting in your body? How much did you actually absorb? How much is available for you? How much? What's the cost? If I ate that, what does that food source take from me as well, or put in me that's also a negative? So what is the cost in terms of what I'm gaining versus what I'm losing? And again, it doesn't seem to be a complete case of everyone's the same. This doesn't seem to be the case. However, I caveat that with cancer patients and people who I've worked with. Let's say, you know, we could argue that unless your cancer was caused by a particular, let's say, drug or radiation exposure or something like asbestos, but, you know, 90+% of cancers, unfortunately, are lifestyle, you know, they're dietary lifestyle cancers, metabolic cancers. And you could argue this group of people are not carbohydrate tolerant. And so their cancers are fueling off of glucose predominantly, again, being aware of glutamate, and insulin. Insulin is facilitating these cells to continue to grow and divide uncontrolled. So that is important, that they try to modulate and manage their glucose. Women can stress. Women can, I mean, men too, of course, but women can be so stressed about that glucose number, the obsession of that glucose number, that the obsession can cause the glucose to rise. So
Yeah,
this is
definitely
a problem. Glucose can rise from running up and down the stairs. Glucose can rise from not sleeping well enough. It can, and this is why I'm saying it is complicated. So you want, this is why I come back to ketones in this respect, because as you know about the glucose ketone index, which is one part of cancer, complementing cancer therapy as a metabolic therapy to complement any other therapies, and that was really developed with Thomas Seyfried and his colleagues, and that's one thing to be looking at, because of looking at the role of what ketones are doing and glucose as well. But again, I bring it back to, because it's telling you that you've brought the insulin down, and as much as we know that glucose obviously is doing feeding, let's say, cancer cells, and ketones can be very anti-inflammatory and re-regulate immune cells to behave in your favor. The bringing down of the insulin is very, very important. So to just focus on glucose without thinking that actually it's more important that you're getting your ketones up in the state of having cancer. I caveat that, because really healthy people don't need to become obsessed with their ketone numbers. But in the state of having cancer, it's more important that you're focusing on the production, endogenous production, so not exogenous, endogenous. Because if you take exogenous ketones, that can look great and it can do great things too, but it's not the same as a signal that shows you're able to produce and ramp up the production of ketones, because that's telling you you've brought that insulin really low. And insulin is the anabolic hormone. It's the growth and divide, proliferate hormone. So you really want to get that down.
Yeah, I think the best application for exogenous ketones would be for calorie restriction and trying to extend fasts, maybe, but not on top of even a diet that is ketogenic. I just feel like people are having their normal diets in the way they normally would, and then they're taking this supplement thinking it's going to give them some magic.
Yeah, I mean, I guess the thing is that with cancer, of course, there's the aspect of your weight, and a lot of medical practitioners, they're very concerned. They're fearful of cachexia, which is absolutely important, because once you get into a cachexic state, it's very hard to come out of that state, and it's actually it's really sort of end stage cancer. It sends you into this cascade. It's terrible. And cachexia, the wastage of the muscles, not just in your arms and your legs, but the muscles that line your vessels, the muscles that your heart muscle, all these things, and that has another role on the bones as well. And so the importance of avoiding cachexia, and so this sort of sits at the position of why a lot of oncologists and other medical practitioners are somewhat afraid of ketogenic diets or getting into ketosis for cancer patients, because it's often just only thought of as a weight loss, metabolic phenotype for weight loss. And I argue that it's not. It's a weight normalizing diet. And so if you
do it properly, definitely. I find that a lot of people aren't doing it properly because dietitians aren't really on board with this. So you'll often still get dietitians saying it's dangerous.
Yeah. And so obviously you need to have in any diet a nutrient replete diet. This is the case. And that doesn't mean knowing what's in the food on the plate. It's also knowing how much of it will you absorb, how much is available to you. And so with the ketogenic diet, and a lot of people are applying it very well themselves. They are figuring it out, but yes, you're right. There are a lot of people who don't. Again, I mean, you could be doing a ketogenic diet with a high amount of, I would argue, not healthy soybean and oils and canola oils, these kind of oils that I would argue are not good to be doing a ketogenic diet, utilizing these. But I know that's a huge other conversation.
Also having loads of carb replacements where it's just loads of sweeteners and foods that aren't nutritionally dense.
Yes, a lot of people usually sort of the first transition into going low carb and ketogenic is to try to mimic their high carbohydrate type diet. And it's sort of natural, because it's naturally instinctive to want to do that, because it's wanting to make it's kind of like, if you look at the vegetarian and vegan world, they make their vegan sausages is to mimic what they had before. It's that same idea. And so in the ketogenic world, when the desserts quite often are made using a lot of not necessarily artificial sweeteners. One can argue that erythritol is not artificial, but still, it's not. These are not nutritious foods. These are not nutritious foods, and they have their own role and effect on gut microbiome and all of these things. So it certainly is important to be cautious. And I would say that with regards to cancer patients that I've worked with, they have played a role. They have played a role where, we all feel like we want a little bit of comfort food. And so they will be making an excess of desserts, ketogenic desserts, but still that I think are playing not such a great role on their health. And then there are lots of other little things. For cancer, there is the time restricted feeding, intermittent fasting, and again, overcoming the fear of practicing it. Some women, in general, I find, unless a woman is very, very overweight, there is definitely a negative for extended fasting too much. Now, I could be wrong. It's just from my working with people. But even still, you don't have to fast more than a number of days. It can just be alternate days of eating, as an example. What time of day you eat, I know that a lot of people necessarily might prefer eating at lunchtime. My working experience, in terms of if you really need to get really high ketones, is actually eating the dinner meal. The 7 p.m. meal is the better meal to be had. And I think that the role of that is structured around your cortisol rhythm patterns, your insulin rhythm patterns, over a 24-hour cycle, your circadian, the ultradian rhythms, and the pulsatile rhythms of insulin too. And when you sum it all up, I've noticed, so I've had people I've worked with who typically would only have lunch, and they couldn't get their ketones above 1.2, 1.3, around this range. And I said to them, just shift your lunch to dinner. That's it, have it at dinner time. And they would just shoot straight past, 2.5 millimoles of ketones and really start to progress much further. And so this is definitely having an effect. Just the time, same meal, just a different time of the day. How crazy, if you think they're only having one meal, the only thing they're changing is what hour of the day that they're having it in. And so that's interesting, because then it really shows you how profound of an effect your hormones rhythm through the 24-hour cycle can have such an effect on other hormonal signaling, such as insulin and production of ketones, and then regulation of your glucose, which will play a role with your cortisol as well. So this does actually apply to males as well. I would say it applies to males.
Well, one interesting thing that I found when I was fasting once is I felt like I was ravenously hungry because I was doing an extended fast. And then I tested my blood glucose and it actually went up, or it was high when I tested it. But then I had just an electrolyte solution. It was just salt, potassium, sodium bicarb, and magnesium sulfate. And I had it just in water. And I had that, and then 15 minutes later, my blood glucose was really low. And then it stayed low throughout the day. And I wasn't hungry. I stopped being hungry after that too.
Yeah.
So there's something else going on there.
100%, absolutely. Quite often when we have ill health, it's not just because we were eating foods that were elevating our blood glucose and having too much insulin and not enough, let's say, fat oxidation and ketones. It's often coming down to as well minerals and nutrients that we're lacking. And so no matter what diet you have, the body needs to have the minerals and nutrients to work properly. And, I think a lot of our food guidelines have come from the idea that, well, if we eat a little bit of everything, we're sort of hedging our bets that we're getting the minerals and nutrients that we need. And I do think that this is where the danger of the word a balanced diet comes from, because the word balance has been conflated with varied diet. So a balanced diet is not the same as a varied diet. A varied diet is that idea of trying to a little bit of everything. But the balance actually really properly, it means getting the balance of all the nutrients, vitamins, and minerals that you need from your diet. And that doesn't necessarily mean a varied diet. A balanced diet can be 3 or 4 or 5 things that provide the balance of everything you need. Hence why a baby in its first year of life can have breast milk, which is balanced. That is a balanced diet for the baby, because it gets everything it needs from that meal, from that one type of food source. And so, we have historical cultures of people. I go back to the Inuit again, where one would argue it's not a highly varied diet, but it's a balanced diet. They thrive on it. And the same as the Maasai, the nomadic Maasai didn't have a varied diet. It was balanced. And so when we talk about balance in terms of the foods that you have, if you were to pick let's say, give everyone the challenge of coming up with 5 plates, 5 types of food, not plates, sorry, but 5 types of foods. Come back to me with 5 types of foods that will provide the balance of all the nutrients you need, which includes the vitamins, the minerals, the proteins, the amino acids, that is bioavailable, that you can absorb. Come back to me with those 5 food sources. Now, you might want to argue, yeah, but life isn't worth living without the variety, and that's another thing. I get it. But in terms of if you are someone who's suffering with a major health condition and you wake up every day with pain or fear that you're not going to live, and you've got children that you need to be around for, or any of these sort of things, then it is arguable that it is about eating what will give you the best chance to improve your body and your health. And so when we talk about, again, like you're saying, your glucose being elevated and feeling hungry because of it, and how other things such as minerals were playing a role, this is very important. Magnesium massively affects the body in terms of hyperinsulinemia, can cause you to be magnesium deficient, but magnesium deficiency can cause you to be hyperinsulinic, both ways. And with regards to minerals, the importance of the minerals is that when you eat certain foods, it can raise your stomach pH so that your stomach is less acidic. And to be able to absorb these magnesium, selenium, zinc, your stomach pH needs to be a low number. Ideally, like a baby's stomach pH is at pH 1 and less. So they have fantastic stomach acidity. So this is to point out that babies don't suffer acid reflux. Healthy babies don't. And so more stomach acidity is not going to be causing you acid reflux unless you've got actual damage to your lower esophageal sphincter. But the lower esophageal sphincter closes based on increased stomach acidity. It stimulates it to close. A higher pH, which is less stomach acidity, causes the sphincter to open up, and you're likely to have these symptoms of acid reflux, which will make you think you have too much acid. But coming back to what has that got to do with minerals, the minerals need to be in a below pH 2, 2.5 for you to be able to absorb them. So a lot of people don't realize this, and they will eat really quite a lot of plant matter foods that can increase the stomach pH, and effectively the minerals from food of any source will precipitate out of solution and not be available. And that might not be yesterday, it might be perniciously over years, and so you become a little bit deficient, just a little bit, and this is going to have an effect on your health. Now for yourself, I know you've been ketogenic for a long time, so what happened then? Well, we sweat we sweat, we go for walks, we sweat, it's hot, it's muggy, you know, we lose minerals there as well. And, you know, if you're fasting, well, you're not replacing them. And if you're fasting and you're being active still, then those minerals quite possibly will need to be replenished. And so this is that fine tuning and being aware of yourself. And it's a learning curve. It's a learning curve for everyone to be able to take charge of your own health, which I think that we have fallen into a trap in our society of passing that responsibility off to medical professionals and no longer being aware of the signs of our health and what we can do ourselves. That's not to discredit the medical practitioners who are very necessary to be there, but knowing those little signs, knowing how to pick up on it. You know, hunger. Most people, if they feel hunger, they think, well, then I need to eat, right? That's the first thing.
And most people don't know what real hunger feels like.
Yeah, and there's other things like thirst. A lot of people, they'll feel thirsty and they'll eat because food contains moisture. So instead they'll eat. But yes, a real hunger is something that many of us, thankfully, really have never had to suffer. But yes, the hunger signal can be from minerals that are not there, and it doesn't. The electrolyte packets that you can get, or you can make from a bone broth, things like this. It's worth experimenting on yourself to see if it's playing this role. And this is why you get some people who fast where they are not fully calorically fasted, they're metabolically fasted. Again, I was mentioning to be in a fasting mimicking diet. So they will actually drink bone broth. And it partly is because of this. It's exactly what you're describing in terms of getting back minerals that most likely need to be replenished and given to the body. And if a person is not in good health, I would argue with the bone broth, you know, potentially adding something that would acidify during the time that you drink to increase your absorption capacity. But again, it's a self-experimentation, whether it's some lemon juice or some apple cider vinegar, or some people it's nothing, they don't need anything. Then the cutting out of certain carbohydrate foods that were causing them to have higher pH resolve the problem already. So each person does have to work that out themselves. And I know it might seem a bit overworking it, but keeping a log of those things can really help you, look back on what worked for me, what didn't work for me in that respect.
I've often wondered in regards to that, we mentioned exogenous ketones, and I used to take them when I was exercising, doing more glycolytic activity and experiencing some seizure activity. I'd experiment with taking them, and I found that I'd get this almost instant benefit. But then I thought, well, hang on, is this actually the ketones, or is it the salts that come with it? And then the next time I had a similar experience. I just had my electrolyte mix that I make up, and I had the same benefit. So I'm even wondering, just when people say that they experience this kind of feeling after they take these exogenous ketones, how much is actually the ketones, and how much is either the other ingredients that are often in them, or the salts, you know? And the one that I was taking that I noticed an actual benefit from was an unflavored one, and not from this company that's promoting them like there's some evangelical Christians where they're just saying, this is amazing, it's going to save your life and make you a billionaire, and you're going to be famous and have a supermodel girlfriend and 12-pack abs, and promising the world to you from having these, you know, these exogenous ketones. But often you'll look into them and you'll say, well, are people experiencing that because lots of them have caffeine in, or all these other ingredients? Then they've got things like guar gum in, and you're thinking, how is that affecting the gut microbiome? And is that stopping you from, is that actually helping you? because when I was trying the ones that were actually flavored, the main benefit I had from this unflavored one, which isn't a company that's widely promoted, I got the best benefit from that. And it tasted absolutely horrendous, but it it gave me that just feeling of, well, that I could just easily not eat for many days. I had instant satiety and I could feel it. I could feel the benefits. But when I was trying these other products that are on the market, these other exogenous ketones, I found that some of them even made me feel hungry afterwards. It wasn't helping at all.
Yeah, I've actually seen quite a lot of people, women, who've gained weight, but men as well, who've gained weight on ketogenic diets, and they really were in ketosis. So this is why I was saying that, it's not a completely weight loss diet. You can gain weight being in ketosis, and that's fine, because it may be that your body is better at a certain weight. So of course, if you're massively overweight and then you gain weight, then there's something going wrong here. But if you are actually at a very normal weight, or possibly very, very lean, and you actually gained weight, I have women who wanted to gain weight, and they went ketogenic, and I helped them to gain weight in a healthy way.
I'm trying to gain weight at the moment. It's very difficult. Yeah. I'm giving myself a year to I'm giving myself a year to get to 65 kilos.
Okay, so
because I'm currently 60, or maybe a bit heavier, because over the past few weeks I've really put in a lot of effort to try and eat more and do more resistance training. But I'm giving myself a realistic target of a year to get back up to that.
That's actually really good, because a lot of people, we sort of, give ourselves a target of 1 or 2 weeks, wanting to see change very, very quickly. And
well, just with my epilepsy, I know that wouldn't be really possible.
Yeah.
I'm even being told now that I don't have epilepsy. And then I was saying, well, why do you think that? And the answer was because I don't have spontaneous seizures. They're not spontaneous. I always know what the cause is. I can always identify it. And I think if I do begin to have spontaneous seizures, that's problematic, because that maybe means some tumors back. Or But for me, it's just, if I avoid all my triggers, and most of them are diet related, or electrolytes, or stress, or all these things, then I don't have any problems. But it's so technically I don't have epilepsy, but I can have seizures, because everyone has a seizure threshold. But
yes, absolutely. I think that a lot of problems come in healthcare world from we don't necessarily have the best classifications of things, how things are classified. It's humans, right? We're humans. We arbitrarily classify things. It's the groups that we make. They're because we base it on patterns, don't we? And let's just say the medical world of the description of epilepsy is spontaneous, and so therefore, if you don't fit that particular bit of the description, then nope, you don't have it.
Well, the funny thing is that if I came off this diet and went back on the medication and was still having seizures, I would be termed as having epilepsy again. So suddenly I have epilepsy, but then managing it off medication, I'm told, no, you don't have epilepsy. It's something else. But we still want you to take the medication for epilepsy.
That's the hard part of I think we are evolving into a newer, different way of healthcare. We're kind of on the cusp of it, which is where the patient is as much their own advocate and healthcare practitioner as the doctor is. And so, we have an access to an incredible amount of information via the internet and books that are published, and the public are, hopefully, it appears to be becoming more engaged with the scientific and medical literature that's coming out, and information is just being shared. And things have changed a lot in 100 years. The difference of how people, when you think back 100 years ago, I mean, doctors, for the ability for them to study, to have access to the information, all these things, it was so understandable that the public layman would go to a doctor and the doctor would literally know everything and so much more. It was so understandable. And we're just in a situation now where, you know, we've flourished from a system that has given education to as many of our citizens as possible. And with that comes people becoming more informed. Now, of course, as much as we've got so much information, you've got so much rubbish information too, but still it is the aspect of the individual being engaged in their health care. You can go see a doctor, come home, go on Google or whatever search engine it is and have a look and read. The ability to read, you know, the rate of reading, you go back, you know, if you go back a couple of 100 years or just 150 years, it's different. And so you can read and start to say, hang on a minute, does that make sense? Or, you know, looking up other people who have similar conditions as yourself, who provide some form of evidence that they've resolved it and they did it doing this, and then you go, well, you know what, I want to give that a try, and then they give it a try, and you know, it's a trial and error sort of thing, which is pretty much what a lot of scientists do, and even doctors do. It's a trial and error thing. And going to your doctor and asking them questions, hard questions, like, how many patients have you treated that have my condition? How many resolved the condition? Rather than manage, how many got worse? Have you ever helped them resolve it or get it into remission? Have you put them on drugs and never been able to take them off of those drugs with not having those problems anymore? They're hard questions, but a lot more patients are asking them now, and it's holding doctors to accountability, and that's not a bad thing. Confident doctors who may not necessarily know what to do, or do know what to do, will not have a problem with that, because it's a learning process for everyone, and it should develop a better relationship between the patient and the doctor. It doesn't necessarily. We know that. We know there are cases where patients are not being helped by their doctors, the relationship doesn't work. And then it is a challenge to go and find another doctor who will work with you, because we have this change now where people want to be actively involved in their own healthcare, where they have an absolute say. And I would argue, without having ever done a study on it, but I would argue that people tend to have better health outcomes when they are more involved in their healthcare. And that's in any aspect that they choose to apply, whether it's they want to go low carb or they want to go vegan, whether it's they want to increase their exercise or do certain things. It's the act of being involved, the act of taking extra measures. It somehow changes the person. It changes how they approach their healthcare, and it has a much wider impact on all these little things that is very hard to account for. And so that's the first thing I would say for a lot of people. If you in terms of gaining good health, and if you have to deal with a doctor, if you're not seeing a doctor, it's one thing, but if there's a need to see a doctor, to become very, very engaged and involved in that process.
What do you think the best way of doing that is? Because you can go and see a functional medicine practitioner, but they're pretty expensive. So
yeah, this is true.
What's the best way of doing it?
There is a movement well, we're in the UK, right? So it is different to America, and so I can't really speak well for how it is in America. But I am also part Hong Kong Chinese, so I'm quite used to what happens over in Hong Kong, and I would say that there is sometimes you pay a little bit more, but in the end you're paying less. Now, I'm not therefore saying go and see a functional medicine practitioner, which might cost an arm and a leg. But if you pay a lot more for one session, or versus nothing if you were going to the NHS, but if you only had to go to the doctor once in a blue moon, then the cost would have been worth it, right? This is one way to look at it. The other aspect is we are actually seeing more and more NHS doctors who are very just a lot more switched on, just a lot more in tune with what patients need. And you do have to dig for them, do some research looking for them, but they're there, they're really there. And then you're getting a lot more sort of younger physicians who are coming in, who are definitely sort of revitalizing. Now, that's not necessarily all of them, but they're definitely revitalizing the system and what's being practiced. So I would say, again, part of what I'm saying about being engaged with your healthcare, it's not a case of, well, I live here, there's the local practice where I am, and I'm just going to go and see whoever's there. Look up who is there. Ask your doctor when you go see them, what is your history with, let's say it's type 2 diabetes, or let's say, you know, it's a condition that your general healthcare practitioner is involved with. Weight, hypertension would be a classic one, dyslipidemia, and asking your doctor, and potentially then going to finding another place where that doctor seems that there's a hints of, well, this surgery, this clinic seems to be doing something different. And because you can find these things out, you can dig online. When you decide to go and buy a house or a car, you go and see many places. You do your due diligence on them. You check things out and you have a look. You know, even if you get some contractors to come in and check the house, you make sure that the contractor doesn't have a history of sort of doing a lazy job, you know. And so if you're choosing that for when you purchase a house, why do you not do that with your healthcare? You would choose. Now, you know, one could argue that, you know, when we have the luxury of the NHS, then maybe it's like, well, you don't get to pick and choose. But, you know, the NHS is also, it's for the public, by the public. Who built the NHS? It's from the people. It's from the people funding it.
People forget that.
Yes. And so the NHS is also held to a standard where we can, as a public, say, wait a minute, we expect a high standard. And so we will, as publics, look for the doctors who are, you know, really pushing certain boundaries and working with the public. It also means facing up to things that are not working, and facing up to potentially healthcare practitioners who need to be, let's say, woken up to get back in the spirit of wanting to learn, to get back into the spirit of going, okay, maybe this isn't right, maybe this isn't working, and be okay with that and open-minded to other things. You know, evidence-based medicine, as it's always nowadays called, although I can't imagine any medicine shouldn't be evidence-based. So but yes, functional medicine practitioners, there are those. Some of them might even be willing to put you in contact with people that don't charge as much. There are some functional practitioners you can just call and say, look, you know, I really need help. I can't afford your fees. Is there a way that you could provide a discount, maybe see me for slightly less time? Or is there a way that I can see someone that you employ that would cost less, a trainee? Or is there an NHS doctor you could recommend me to try and get an appointment with? You know, we're humans, and you can totally appeal to people and ask them. And, you know, I rarely meet terrible, terrible people, you know, and just, you know, don't ask, don't get. Just ask people if they can point you in the right way.
In terms of blood tests you can get on the NHS, I feel like a lot of them are pretty useless because they're not testing what you actually need to look at. But all I can think of really is the vitamin D blood test. But others I don't feel like they give you the full profile. Like if you get a full blood count, you're not really getting everything. You're having some things, some important measures are being missed out. And same if you have a thyroid test or any of these, just often you're getting some of the picture, but not the whole picture.
Not the whole picture, it's true. This is very true. And certainly if you're a patient who is a bit more aware of what you think you need to be able to see, then you can ask for this. And again, some doctors may be more facilitative than others, of course, because it's a cost issue in them having to manage their costs. 99% of times your doctors really do want to help you. So, you know, if you talk,
I can always get the vitamin D test. I get that one all the time, but just other tests. So if I have, say, like a triglycerides test, and then they do the cholesterol and, you know, the LDL and HDL, and then they go crazy that the LDL's high, but then the HDL's really high, but they're still going crazy that just the LDL's high. And then even though the triglycerides are just next to nothing, It's
Yes.
just
Well,
why,
this is that
you
part
know.
of, you should be reading things in a context, right? And I think that this is one of the downsides of specialization. What usually happens is you sort of get so specialized that then you'll have someone else who's in charge of just, saying, well, that doesn't fit in the reference range, that doesn't fit in the reference range, bad, 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 good, bad, 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 bad. And it's just the bad that we focus on, and we don't see the good with it. And the doctors are really busy just trying to get everyone through. And so it's a formula. And the formula that isn't necessarily updated very well, or taking something in a holistic context. And so, yes, we have a problem with this. Standardization is difficult. We don't have a standardization of having what we would consider the necessary markers all the time. And even when we do have standardization, it can come with its own problems, because then it standardizes the treatment, which may not necessarily be the best treatment as well. Vitamin D is definitely a good test to have, I would say. Absolutely. It's one of the really good ones. Now there's the whole argument, is it a marker or maker of good health? But it doesn't kind of matter, because if you have low vitamin D, whether it was a maker or a marker of it, it tells you there's a problem. So just knowing that is important.
Especially in the times of COVID. It's good to have high vitamin D.
Yeah, it definitely tracks with. I think there's a lot going on now with regards to vitamin D and its role, whether it's because people are vitamin D deficient and therefore more susceptible to catching respiratory illnesses and having worse prognosis, or it's just a marker. But even if it's a marker, knowing if you are deficient then tells you, well, okay, what do we do about this to not be in an at-risk category? And then there's the other research that seems to infer that actually vitamin D has a role. It has a role in catching a virus, a respiratory virus, and it also has a role in the inflammatory response as well. And with regards to vitamin D, I mean, it's quite incredible the amount of things that it can do in the body. I mean, first and foremost, it's not actually a vitamin, it's a hormone. And I quite often will refer to it as hormone vitamin D.
There's a great book that I had. It's massive. It's like a textbook. It's called Vitamin D and Cholesterol.
Mm.
It's a massive book, but it's absolutely brilliant. It just tells you just everything about this hormone. And
yeah, it's sometimes a bit boggling that it does so many things. Although it's like, wow, I mean, really. It plays a role in your endothelial cells in your lungs in producing cathelicidin, which is an antimicrobial. So of course, if you're naturally producing an antimicrobial very well, then it's arguable, well, a virus is not going to be able to take a stronghold inside of your lungs so easily, right? So that's one of the things that vitamin D does, but it also plays a huge role in the coagulation status inside of your bloodstream. So cholesterol sulfate, which increases the negative charge around your red blood cells, your white cells, platelets, and your endothelial cells, so that they don't stick together. The process of sulfation, of bonding the cholesterol and sulfate together, and heparin sulfate is another one. It involves vitamin D playing a role in that process. So low vitamin D, you're going to have a diminished capacity on increasing these cholesterol sulfate and heparin sulfates that function in antithrombotic processes, which are really important, because as we see in the particular case of COVID-19, there seems to be a much higher, statistically higher rates of embolisms, pulmonary embolisms and cerebral embolisms. And that does certainly link back to hyperinsulinemia playing this role, because hyperinsulinemia actually dysregulates vitamin D metabolism. So even if you're consuming vitamin D rich foods, which still would be of benefit, the vitamin D is lipophilic. So it's attracted to fat, and hyperinsulinemia drives fat to stay inside of fat cells and to make more fat cells. And so vitamin D is then taken up it's accreted, it's sequestered into the adipocytes, so it's kind of not available to you. And that's just one level of problem, because the next is that vitamin D has to be activated, whether you made the vitamin D endogenously. So it's absolute raw material to make vitamin D is cholesterol. So the first thing it's made from is cholesterol. So this makes you start to question, well, is it therefore bad to have high cholesterol? Because if you need enough cholesterol to make vitamin D, perhaps it's not such a good idea to decrease how much cholesterol you have in your blood by decreasing the carriers that carry cholesterol. Because, you know, you decrease the protein carriers, then there's less cholesterol available. So that's another thing. So cholesterol is turned into vitamin D by going out into the sunlight. But then that's only one step. It then has to be activated in the liver, and then it has to be activated in the kidneys. And it can be activated inside of, actually a massive one is bone cells in osteocytes and osteoblasts. They activate as well. And hyperinsulinemia negatively affects that particular activation, which is called hydroxylation. It's where an OH, oxygen and hydrogen, is added onto the molecule. It's hydroxylated. And the final hydroxylation, which really gets you to biologically active vitamin D, is called a 1-alpha hydroxylase. It's a CYP enzyme. So it's situated on the inner mitochondrial membrane, and it has a ferredoxin part inside of it. It's affected by redox states of cells. And I know I can get firing into the biochemistry of it, but it comes into this concept of when you use glucose a lot, for fuel, you decrease the intracellular NAD plus pool. So that's nicotinamide adenine dinucleotide. It's a precursor. It's a co-substrate. It's needed for certain other molecules, certain other enzymes like sirtuins. It's needed. It's a cofactor. And when you use glucose a lot, it gets depleted. When you burn fatty acids, so glucose will to make 2 acetyl moieties, glucose uses 4 NAD pluses. Fatty acid oxidation uses 2, ketones, beta hydroxybutyrate uses 1, acetoacetate uses none. And this really matters because it ultimately dictates how much NADPH is made, and a few other things, but the NADPH being important because hydroxylation of vitamin D to get it to a biologically active state is dependent on NADPH, because that's what activates the hydroxylase enzyme, and magnesium. So it's not just
magnesium does so many things.
Yes,
and if you try to count it, it's well over 500 enzyme reactions. It's
incredible. Well, magnesium is needed for vitamin D transport. So, you know, even if you've activated it, or even if, you know, you've taken it, you need to be able to transport it around your body. So again, magnesium is going to be playing that essential role as well. And just to quickly come back to the coagulation, where I was talking about the role of vitamin D in coagulation, it is further complicated by the fact that a dietary habit that frequently elevates blood glucose will increase the coagulability of blood, because it causes the liver to increase the release of clotting factors. Then insulin is required and often stimulated to be secreted or injected exogenously, because type 2 diabetics are given exogenous insulin. Insulin inhibits those clotting factors and clots from being broken down, stops that sort of feedback system. And so it's a molecule called plasminogen activator inhibitor 1, and insulin prevents the breakdown. So it just increases the clotting rate. And so now you've got low vitamin D that's sort of not allowing for the anticoagulant, the endogenous anticoagulation that the body normally makes, which is the heparin sulfate and cholesterol sulfate. And then you've got glucose, not necessarily hyperglycemia, but regular repeated elevated blood glucose. Then the insulin to try and counter the elevated glucose, and you've got the sort of perfect storm. And so it's a real problem, and it makes sense on as a evolutionary standpoint. Because if we were in a high stress state, let's say hunter-gatherers, you're in a high stress state, potentially at risk of being hunted by another animal or harmed, you would have a high spike of stress, cortisol, and release glucose for the availability of muscles should you need to run. But in addition, in case you were to experience harm, whether it's from another animal or from falling and cutting yourself, and you would not want to bleed out. So the body has this system to upregulate its ability to clot, and it certainly wouldn't want to immediately break down those clots as well. So the insulin partly there to facilitate rapid glucose uptake, but also partly there to ensure that if you come to harm, that the clotting would work and be effective. So this is an acute, sort of an evolutionary reason, of an acute reason why this system even exists. The problem is we're turning an acute situation into a chronic, repeated situation, which then pushes forward the pathological development of the diseases, because we shouldn't always be in a state where we're just ready to start coagulating and we can't anticoagulate, and we get the vascular problems that we do that can then affect our cardiovascular system, our neurological, our central nervous system, and our risk on things like COVID-19, where we see the at-risk patients really are people who have metabolic conditions, and I would argue hyperinsulinemia conditions, although not entirely, because we know that there are type 1 diabetics who are at risk as well.
Do you feel like that's why we're constantly being told this isn't just a respiratory disease, it's affecting multiple tissues? Is it actually doing that directly, or is it due to some sort of insulin resistance or these clotting factors? Is it having like an indirect effect? You hear patients who are saying that they're having these moments of delirium and just these strange neurological effects. Is that actually something to do with just the virus itself, or is it the response of the metabolic status of the patient? That's what I've often wondered. Would this happen in a healthy person?
Well, I think that what needs to be investigated is the healthy persons who have had confirmed cases, because what were all of their symptoms, to really investigate, in detail, because the argument is, the fundamental is, does the virus actually actively do these things in these various regions of the body, or are those symptoms a sequelae, a consequence of being already not in good health? The virus sets you up for certain things, and then boom, 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 you can end up with these downstream phenomena. And we certainly notice this with hyperinsulinemia. You'd be hyperinsulinic, and then you end up with, liver problems, then you end up with kidney problems, then you end up with a heart problem. And so it's consequence, and it may be the case with COVID-19. You know what, it could be a mixture of both even. How much do we know in terms of the respiratory system? It is a barrier, but it's also an entry point into the body. And so, how good is your barrier? And for some people, that might be the stop point. So you get flu-like symptoms. For other people, it progresses further in, where virus can actually further infiltrate into the body, and then maybe that's going to cause so much more other problems. Or alternatively, the virus does sit at the epithelial layer in the lungs, but takes such a stronghold that it then causes all the cascades. If you're hyperinsulinic and you've got an excess risk of thrombi, embolisms, and I think the reality is it's a mixture of all of them, isn't it? Because different people come with their different setup, so to speak. And so this is why you see some people. It's not 100% everyone loses their sense of smell and taste. Everyone gets a fever. Everyone gets embolisms. It's not. Which, if all of those cases have confirmation and a confidence level in confirmation of having caught COVID-19, so we can know for sure that they each had it, they do seem to present with, there are certain things that are strong, they're much more significantly showing up. So with regards to what markers can be measured, so in terms of elevated ferritin, elevated D-dimer. Now these are markers, they're not necessarily makers. And I argue that elevated ferritin, bilirubin, and D-dimer are all to do with the breakdown of damaged heme, because the breakdown of damaged heme creates these, and so hyperinsulinemia does this by itself without COVID-19. But if you put on top of it something that is really stressing the respiratory system in terms of oxygen saturation capacity, then it's arguable you will end up with an increase in ferritin, biliverdin, bilirubin, and D-dimer. D-dimer is a marker of trying to break down coagulation, and the consequence of that particular process, that breaking down, which is by heme oxygenase, is the making of carbon monoxide. And so how many of these people are suffering carbon monoxide poisoning without knowing it? It's this pernicious carbon monoxide, which, by the way, carbon monoxide increases deep vein thrombosis, which then increases the risk of pulmonary embolism. So you see that cycle going up there. So there is always that issue is whatever we're measuring, but symptoms, in terms of actual symptoms, right? The breathing, energy levels, nausea, temperature, fever, bowel discomfort, movements, diarrhea, things like that. But we know that a lot of illnesses also have the same symptoms. Influenza A, influenza B, common cold, COVID-19, they have a lot of similar symptoms too, right? So the body reacts. Being sick, the body reacts. It presents with those sort of symptoms. And of course, we know that people who are very hyperinsulinic for a chronic amount of time, they do not fare well in general with illnesses, with communicable illnesses as well. So they are the group who tend to catch communicable illnesses much more. And again, that's because their system is not robust. When you're healthy, you really are better at not catching things, or actually catching things but not actually seeing any symptoms, because your body will catch it and go and deal with it. And
I feel like the sleep is so important with that too. Even if you're normally metabolically very healthy and you have a fantastic diet, if you have one night of poor sleep, you can be much more prone to getting influenza.
I would agree with that. We're prone to many health ailments.
What do you think about people taking exogenous melatonin for COVID? Because there's been lots of interesting studies on that.
There has been.
It makes me feel like, would I want to optimize natural sleep as well as I could by getting AM sun and then just ensuring I have an adequate sleep routine? Or would I want to continually take melatonin? And what's that doing for me? Taking, again, it's a hormone, but it's a very potent endogenous antioxidant. What's it doing if I'm continually taking that, even though I've seen these benefits?
I think that because we know sleep has benefits, it has benefits to health. And we also know that melatonin can make you sleepy. And so the idea is that melatonin is therefore having this role. Its role is on sleep, and therefore its role is on immune risk. But I don't think that's actually the mechanism of how melatonin is having a big role, actually, not on the sleep, although that's the benefit. There are people who actually take melatonin who can't sleep. I've really noticed this.
It seems to be having additional benefits, even if you're taking it even first thing in the morning and you're taking it every few hours. There seems to just have, it has all these other actions that could benefit you.
Melatonin works on the mitochondria. So it's protective to cardiolipin, which is a fatty acid in the mitochondria. Cardiolipin is present in bacteria, and mainly in the mitochondria, a little bit in peroxisomes and lysosomes, but fundamentally the mitochondria. And it kind of fits with the endosymbiont theory of mitochondria being a proto bacteria, and so not really of us, but being part of us. And cardiolipin is this fatty acid. It's this fat molecule that it's really fascinating how it's shaped. So it's got this central knot and this hinge, and these hinges on the ends as well, and sort of 4 prongs. And the way it moves, it governs the catalytic activity of the inner membrane, the electron transport chains. And so with regards to cancer, there's a really quantifiable decrease in cardiolipin, which really then relates back to the amount of electron transport chain there is and how well it's functioning. And reactive oxygen species that are primarily produced in the mitochondria damage cardiolipin. So you need things to protect cardiolipin. So insulin increases a molecule called ceramide. This research was really some great research that I really love is by Benjamin Bickman on this. And the increase of ceramide 2, C2, specifically increases mitochondrial ROS, and that's going to have this effect on the membranes. And so cardiolipin, melatonin really protects the cardiolipin, which ultimately protects the electron transport chain, which again comes down to you need the electron transport chain to activate vitamin D, as another example of how they're all linked. So this is the role of what melatonin is doing. That is not a sleep role. It's not to do with sleep role. It's not to do with gene regulation on the circadian rhythm either. It's a very direct role onto the mitochondria. Which we know that healthy mitochondria signal to the nucleus to behave in a particular way in terms of what's expressed genetically. So unhealthy mitochondria still signal to the nucleus, but they send a different signal, and they tell the nucleus genes a different set of genes to be expressed, which can be very pathological. And so melatonin is having this role here. Now, I'm a strong believer that the best thing to do is to do the things in your daily life to increase your own body's ability to produce these things. That being said, it is true there are people who can't. They can't, whether it's because of their work, whether it's because of mobility, or everything they do naturally is still just not enough at the early stages. And so this is where you need to make the decision of, should I supplement with an exogenous melatonin? And again, the complexity of just deciding what is the right one. If I do, what are the other fillers that are inside of that supplement? It is a bit of a minefield to try and figure those things out. This is for sure.
Would taking 5-HTP not help those people, taking a precursor to melatonin? Or does that not work for some people?
We don't know. We don't know. I mean, some people really do take 5-HTP quite regularly, and then swear by it, and other people don't even know about it or don't really see any effect. And I think that it is difficult to there are lots of studies, but still difficult to really discern this group of people would do this group of people would do that, because again, you have to come down to 5-HTP is hydroxylated tryptophan. It's sort of a precursor, the next level activation of tryptophan, which one would normally get from your diet. And that goes on to in your intestines and your enterocytes to then feed forward for the production of serotonin and melatonin. And so then the question is, how much is getting shunted off to serotonin, where you may be depleted as well. So this is the thing. It certainly isn't dangerous to experiment. This is the thing. If you can look at something and go, well, it's not dangerous to take, there's no massive downside, why don't I experiment in that respect? Be your own scientist. And again, choosing your supplement of choice, you don't want many things in there, because then you don't know what's doing what really in that respect. But 5-HTP, I would say, has some benefits either way. It has some benefits because of what precursor it is. But yeah, some people have this fear of, well, I don't want to take a hormone, but that's like saying I don't want to take vitamin D, which is also a hormone.
Well, yeah, we have this funny thing in the UK where you can't get melatonin over the counter, and it's very difficult to get from your GP. So you have to get it from these websites in other countries, which is very easy to do, and they're legitimate places to get it. But it's just funny how you have to do that. Yeah, it is difficult. Different countries, different regulations. This is the thing. That's the UK regulation. They haven't made it illegal for you to have it, though. So no. It is just more difficult to source it. This is true. And that I've managed to get it fine, and I have loads of it, but it's just I have like a stash, but you just have to know where to get it. Yeah, that's true. And if in the meantime you can't get hold of actual melatonin, then that would be the natural logical step to get 5-HTP, and then just be aware of not getting 5-HTP with inside of supplements that have a lot of rice fillers or carrageenan or other things that
may not be necessarily ideal for your intestinal flora and gut health in that
It's
respect.
definitely the main problem with a lot of supplements is the fillers.
Yeah.
One brand that I think is pretty good is Thorn Research. I feel like a lot of just with most of their products that it's not so bad. And also their products are researched quite thoroughly and actually tested on real people. And you can access that data. I think that's helpful to be able to look at, because if you're spending money on something, you want it to actually have an effect.
That's true.
I want it to be at therapeutic doses.
Yes, yeah, that's the main thing, is the therapeutic doses as well, that has been assessed in availability to the body, in that respect. But it kind of also comes down to why I also look into why do people feel so good when they eat pasta, or people feel so good when they eat prosciutto, and the thing is, both those foods are really tryptophan rich foods. So pork-based foods, prosciutto and hams, are very rich in tryptophan, but so is wheat. Wheat is also rich in tryptophan, but one of them has an effect on your blood glucose much more negatively, let's say.
Yeah, one of them you'll get a kind of a high from it, and then you'll feel terrible. Yeah. And the other one you'll still feel good. I find that if I eat prosciutto, it's very satiating as well. I can't eat lots of it.
Yes, this is very true. And so where I do see people say, well, it's a cost issue, I say that might be the case at the beginning, but ultimately, if you're less hungry, you will eat less and you will save in time and money and in your health in that respect. And so, yeah, it's always this sort of risk-benefit, cost-benefit ratio that you have to weigh up in the end.
One thing we were talking about once, just in terms of COVID and the fact we have to wear masks now again, is just you mentioned copper masks. Where can you get that from? And what's the benefit? Were you not mentioning that? Was that something else?
No, it was copper in hospitals and things like that.
But I think I saw copper masks as well.
Okay, so I mean, there are copper sprays, right? There are sprays that you can put copper into and sort of saturate masks, and there are things that can be done where you've got more of an acidic layer on one part of a mask versus another. And I think this might be a bit too much for the general public to be sort of overly taken on board. But copper is a very interesting one historically, because mothers would often, if water or food is not clean, especially water, if your children have diarrhea, you instantly know. And so historically, there used to be copper mugs and copper jars and tankards where water was left in it for like half an hour to an hour before it was drunk, because it was antimicrobial. It really worked really well to prevent against diarrhea in families. So copper, there's a lot of research of copper being applied on handlebars in hospitals and things like that, because it would increase the antimicrobial activity and really decrease the transmission of communicable diseases. Now, I do want to prefix, though, that I'm not a person who advocates being a germaphobe. We evolved as the robust humans that we are because we do catch things. We actually, it's how we have a great robust immune system, and it is from the micro dosing of being exposed to pathogens. Of course, I'm not saying therefore catching adenovirus or novavirus that's going to wipe you out is a good thing. Of course not. But generally, as we've always understood, children, they go play outside and climb some trees and get some mud in their fingers, and they taste everything. Babies lick the floor. It is within reason and with common sense. But if we try to avoid things too much, we actually may make ourselves much more vulnerable. And so it is a difficult situation to decide with regards to wearing masks and preventing infections versus not. And I think that there's a sensibility part of it. There are people who are at risk in our communities, in our society. There are people who have health conditions where they really need to be careful, and other people who are super healthy who may not have that same worry. But if we know we're going into certain environments, then it may be just a case of, I'm going to take a little bit of extra care. I'm just going to take a little bit of extra care so that whether I'm an at-risk person or I'm not an at-risk person, I will cover up in these areas because it's just better for the community to do so. But in other situations where you're not an at-risk person and you're going out for a long walk and you're not really near other people, not to cover up in that respect. And even if you come near people that's around other younger people, you're not necessarily putting other people at risk, and that's what I mean. And you don't have people at home who are vulnerable that you could therefore potentially put at harm. Because we do have to weigh up that balance between having a communicable infection that is certainly not good for very at-risk people, but in the majority of the younger population is really something we can handle very well. And as much as you may want to avoid this infection, you could be doing it at the cost of avoiding all other not so dangerous exposures to other pathogens that builds your immune system. And so it's this kind of like pay now, you sort of avoid it now, but pay later, where, I might avoid catching something that's not very dangerous to myself in particular, because I'm low risk, but have therefore avoided all the normal things I would have been exposed to that had kept and engaged my immune system to make me have the robust immune system I have. And then subsequently, a year or two down the line, I get wiped out by a common cold because I didn't actually keep training my immune system. And it is hard. It's hard for the government to give advice because they're trying to give advice to everyone. And blanket advice rarely is the best advice. It's usually much more nuanced than that.
Well, I stopped cleaning my shopping because I thought, well, if I'm going to get it and I feel like I'm going to, everyone's going to get it at some point, I might as well get it from some packaging, even though there's very little evidence that you can even get it from surfaces like that. I just thought, well, the viral load will likely be pretty low, so it's probably the best way to get it.
Yeah, and I think that it's August now, and you could argue that there has been some attenuation of the virus. You could argue. I don't know that for sure.
It's probably weaker.
What happens naturally in nature, and this virus is now being out in nature wherever it's come from, it's been out, which means it's passed through multiple humans. And the way that viruses work is as they pass through multiple humans, the humans the ones that survive to propagate more tend to be the less dangerous ones in actual fact. And so this is an attenuation process. And so so we have had some horrific flus that have gone through that same process. So one could argue that one definitely the research has to be done on it, I suppose. You know your own health very well. You yourself know what happens when you catch a cold. I mean, I would say these sort of things are important to know in each individual person. So for example, some people say, whenever I catch a cold, I am out for 2-3 weeks. It's just devastating on my body. Well, this is telling you something. It's telling you that, well, my body's not necessarily in the best of health. So aside from avoiding catching something that's going to wipe you out, which is certainly advisable, at the same time, now is the time to start working on your baseline health, so that should you come into contact with something as a communicable respiratory condition, you will be better posed to face that challenge in that respect.
Yeah, it's an interesting situation. I was reading that the European strain of the virus it's more transmissible, but if you get it, your symptoms are less severe than if you were to get the Chinese strain of the virus. And then the US strain, or the strain that's in the Americas, is a different strain to both of those as well. I don't know if it's more or less transmissible, and I don't know the severity of symptoms you get, but definitely it's been communicated that the European strain is more transmissible, but it's less severe than the Chinese strain, which is interesting.
And then the question is, if you've been exposed to one strain, does that provide some level of warning in your body that gears you up to better face the other strains and not potentially catch it, or not potentially have any massive downside? That would be an interesting thing to to see, actually. I mean, we wouldn't want people to actually literally have to suffer that and see, but you know, invariably I think that we will find things like that, and let's find out, certainly for the benefit of the European population, if that is the case, because then that would mean that people who have actually been exposed, potentially, whether they have antibodies or don't have antibodies, but they've actually, their immune system has had the challenge and come to recognize the strain that's in Europe, should that confer some form of protection against other strains, would be interesting and beneficial for the Europeans at the very least.
What are you, to change the subject, what are you working on at the moment?
So I'm waiting for a paper right now that's been in submission and gone through review and gone through all the very painful process for publication. So hopefully that's going to come out. And then I'm working on a paper with my collaborators, Catherine Crofts and Kenneth Brookler, which is on hyperinsulinemia and bone fragility. And this is where I think that within my PhD research, my work is much more focused on Alzheimer's disease, brain cancer, and brain cancer and ketogenics. But I decided to take on this challenge. I was invited by Catherine and Ken, and it's been amazing and very hard, because I'm just amazed at how much bone tissue, living bone tissue, plays a huge role in our health to a level that I underestimated, because it's kind of an unsexy subject. Most people sort of think, oh, it's bones. I mean, even osteoporosis, whatever, it's bones, you know. But it's not. It's really not.
I'm actually writing a lot, but I'm doing a writing project at the moment. I'm writing it's an ebook on gadolinium toxicity. Specifically with a specific focus on brain cancer, because again, that's affecting bone marrow quite dramatically, and also just general immunity, and it's impacting on the Warburg effect in cancers, and it's contributing to insulin resistance, and it's doing all these things. And so it's been shown that it looks like it's actually worsening prognosis for, and possibly contributing to recurrence for brain tumor patients. So I've decided to write about it and see.
What goes on in bones is just wow. I mean, this is the thing, is that to look at cardiovascular disease, when we look at cardiovascular disease, that's where you see the symptom, but you kind of almost need to look at the liver and treat the liver to fix the cardiovascular disease. And I would say that's the same argument with regards to other conditions in the body. So, and that's the case with regards to bone. You know, it's so alive and so dynamic, and it's an endocrine tissue. The bone as a whole, not just as a scaffold, is an endocrine tissue which hugely regulates the body. I mean, osteocalcin itself goes through the blood-brain barrier into the brain. And of course, you have the bones in the cranium and the ear area. But when you think about your immune cells coming from your bones and your red blood cells coming from your bones, then fundamentally your whole body relies on that, doesn't it? You know?
And you have this crazy thing. If someone has osteoporosis or osteopenia, the GP will give patients a supplement which is high in calcium and vitamin D too.
Yes.
So you don't really want to be taking supplemental calcium, and on top of that, you're not really getting any benefit from vitamin D too.
Yeah, there's definitely going to be better ways to treat this, for sure. My belief is obviously it's a dietary, not the only, but dietary practices are going to have a much more profound effect. We kind of want to always think of things in the sense of bang for your buck. What thing is going to give you more bang for your buck? And to me, you know, changing your dietary practices are going to give you so much more bang for your buck, much more than a supplement's going to. And again, like you said, you know, taking a calcium supplement or a D2 supplement they come with possible problems. I mean, calcium needs to be regulated where it goes. You know, it is essential. The ability for any of your muscles to contract, your heart muscles, these smooth muscles around your vascular system, they rely on calcium. So it's very important, but the calcium has to be in the right place. If it's in the wrong place, it causes problems. Neurons, to be able to fire, to not fire too much, to be modulated how much they fire, is dependent on calcium. But again, too much calcium can be toxic. And so where that calcium is put when it comes into the body is so important. So, you know, calcium, what does it need? It needs K2. It needs K vitamins, because the K vitamin affects the role of how calcium is taken up and then made available or not available to the bloodstream. K plays a role. It's called carboxylation, and the K is necessary as a cofactor. And so just having calcium supplementation without K, and this is kind of why cheese is so good, raw, healthy, natural cheeses, because it happens to have the calcium in the correct format with the K vitamins as well. And often D as well. So nature figured it out first, and quite often figured it out in the packaging that was best for us as well. So I
think the ratio with magnesium helps as well. Just magnesium helps to regulate calcium. So
yes, it does. Yes,
having a good ratio of calcium to magnesium is good.
Yeah, it's true. So yeah, the bones. So this is what I'm working on. And it's been a huge fascinating learning curve, and it never stops. And I think that's just something fundamentally important for all of us as scientists, all of us in the medical healthcare profession, and the public. Not just people who are in the healthcare profession, but the public is needing to continually learn, which is a combination of gathering information, knowledge, but also working around it, thinking about it. Does it make sense? What's the evidence there? What's logical? So it's the critical thinking with that information. You know, you can have a lot of information and not critically think about it. And it's something we all need to apply. And I guess constantly worry that we're not just self-affirming our own beliefs, you know?
Well, that's what good science is. You're trying to prove yourself wrong rather than right. Yeah.
And I think maybe it's what drives me to some degree is a nervousness. But what if I'm wrong? What if I'm wrong? What is that? Check. Well, you know, it's just so instinctive, I think, for us to want to find things to confirm our belief. It's just completely natural. And when people like you and I are hoping to help people who are not well, I worry. I worry that I could give them advice that could harm them. And so it does make me, that nervousness is kind of necessary. I think it makes me keep me on my toes with what I continually try to learn to sort of double check myself in some ways, you know, and as you research more, as you read more, as you potentially conduct more experiments, if you're a scientist, it's to try to test the strength of your hypothesis, which means to try to break it in actual fact, because it's not to try to prove that I'm right in that respect. It's to really try to break the strength of your hypothesis, because if you can't break it, you strengthen and solidify that hypothesis. But if you do manage to break it, even just one time, you know, put a little crack in it, you have to question that hypothesis and be okay with saying, maybe that's not so good, and then have to change it, not make a paradox or sort of, you know, ad hoc hypothesis to it, but potentially have to throw that hypothesis out and go, I have to start again, you know, because people's lives are dependent on this, you know. Yeah,
I think we'll leave it there.
Yeah,
thanks for the chat. It was really good. Is there anything else you'd like to say as a parting note?
No, that's it. Thank you very much. It was lovely, really lovely talking.